piece of polyvinyl chloride, or a PVC conduit used to protect wires, is classified as a raceway. Article 350.1 of the National Electrical Code, or NEC, defines a raceway as an enclosed channel designed expressly for holding wires, cables, or busbars. This definition clearly encompasses the use of a PVC conduit for containing and protecting electrical conductors. It is important to distinguish this from a protection device, which is specifically designed to protect electrical equipment from overcurrent or short circuits, such as circuit breakers or fuses. When wires are enclosed in raceways, the NEC requires that they may need to be derated, meaning their ampacity must be reduced to account for the reduced heat dissipation. This is because the raceway can act as an insulator, preventing the wires from dissipating heat as effectively as they would in open air. The NEC provides derating factors for wires enclosed in different types of raceways in Table 310.16, and these factors are essential for ensuring the safe operation of electrical systems. For example, wires enclosed in rigid PVC conduit under certain conditions may need to be derated by a specific percentage. The exact percentage depends on the number of current-carrying conductors in the raceway and the ambient temperature. The NEC does not specifically address PVC pieces used to protect wires as raceways in every single instance. However, Article 363, which covers electrical conduit systems, provides general requirements for the installation of raceways. This article, along with other relevant sections of the NEC, should be consulted to ensure compliance with all applicable codes and standards. To further clarify the concept of raceways and derating, let's delve into some additional details. Firstly, the purpose of a raceway is not only to protect wires from physical damage, but also to provide a defined path for them, making it easier to install, maintain, and modify electrical systems. Secondly, raceways can be made from a variety of materials, including metal, plastic, and fiberglass, each with its own advantages and disadvantages in terms of cost, durability, and resistance to corrosion. Thirdly, the type of raceway used will affect the derating factors that need to be applied to the wires. For example, metal raceways typically dissipate heat better than plastic raceways, so the derating factors may be different. Furthermore, the NEC provides specific requirements for the installation of raceways, including the spacing of supports, the type of fittings that can be used, and the maximum number of wires that can be installed in a raceway of a given size. These requirements are designed to ensure that the raceway can adequately protect the wires and that the wires can dissipate heat effectively. Table 310.16, which is referenced in the context of derating, is a crucial resource for determining the allowable ampacities of insulated conductors rated up to 2000 volts based on the temperature rating of the conductor and the ambient temperature. The table provides ampacity values for various conductor sizes and insulation types, and it also includes correction factors that must be applied when the ambient temperature is higher than the temperature listed in the table. In addition to Table 310.16, there are other tables and sections in the NEC that provide guidance on derating wires and raceways. For example, Table 310.15b3 provides adjustment factors for more than 3 current-carrying conductors in a raceway or cable. These adjustment factors reduce the allowable ampacity of the conductors to account for the increased heat generated by multiple conductors in close proximity. It's important to note that the derating requirements in the NEC are based on the assumption that the raceway is installed in a way that allows for adequate ventilation. If the raceway is installed in a confined space or is covered with insulation, the derating factors may need to be increased. In these cases, it's best to consult with a qualified electrical engineer or inspector to determine the appropriate derating factors. When selecting a raceway for a particular application, it's important to consider the environmental conditions to which the raceway will be exposed. For example, if the raceway will be exposed to direct sunlight, it should be made from a material that is resistant to ultraviolet radiation. If the raceway will be exposed to corrosive chemicals, it should be made from a material that is resistant to corrosion. In addition to the material of the raceway, it's also important to consider the size of the raceway. The raceway should be large enough to accommodate all of the wires that will be installed in it, with sufficient space for future expansion. The NEC provides guidelines for determining the appropriate size of a raceway based on the number and size of the wires that will be installed in it. It is also critical to understand the difference between conduit fill and conductor ampacity. Conduit fill refers to the percentage of the interior cross-sectional area of a conduit that is occupied by conductors. The NEC specifies maximum allowable conduit fill percentages to ensure adequate space for heat dissipation and to prevent damage to conductors during installation. Conductor ampacity, on the other hand, refers to the maximum current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. Derating factors are applied to conductor ampacity based on factors such as ambient temperature, the number of current-carrying conductors in a raceway, and the type of raceway. Understanding both conduit fill and conductor ampacity is essential for ensuring the safe and efficient operation of electrical systems. Selecting the appropriate type and size of raceway, as well as applying the correct derating factors, are critical steps in the design and installation of electrical systems. Failing to do so can lead to overheating of conductors, insulation breakdown, and even electrical fires. Therefore, it's always best to consult with a qualified electrical professional to ensure that your electrical system is installed in accordance with all applicable codes and standards. The NEC is a comprehensive document that covers a wide range of electrical topics, and it's essential for anyone involved in the design, installation, or maintenance of electrical systems to be familiar with its provisions. While it may seem daunting to navigate the NEC, there are many resources available to help you understand its requirements. These resources include online training courses, seminars, and publications. In addition, many local electrical inspectors are willing to answer questions and provide guidance on interpreting the NEC. By taking the time to learn about the NEC and to consult with qualified professionals, you can ensure that your electrical system is safe, efficient, and compliant with all applicable codes and standards.